Thank you. And thank you for the invitation to be here and for coming. Mike did me a favor by doing the poll in the beginning because I was going to do that also. But I do want to see the hands of the nutritionist one more time. Okay, thank you. Because I have a group of students in here and I just wanted to make sure their alliances were lined up appropriately. Some of them are co-mentored with Kent Weigel, so I won't make that student make a decision. But I just want to make sure they're associating as nutritionists here. All right, so the reason that we have these long-running jokes about nutritionist perspective or geneticist perspective, I tend to be a very loud person, so I think the microphone is maybe unnecessary here, is something that Mike alluded to. How do we measure and quantify feed efficiency? And this really seems at surface value to be a simple story, right? The cow eats an amount of feed, and she makes a volume of milk or an amount of milk. And therefore, feed efficiency is simply put a kilo of milk for how many kilos of dry matter intake. However, the story is rarely that simple, right? So we can start overcomplicating this and getting down in the weeds pretty easily because, yes, cows eat an amount of feed, but as I stress when teaching nutrition all the time, they're eating an amount of energy, an amount of nitrogen, an amount of each of those nutrients, not just an amount of feed. And a ration we put in front of her would have a different amount of energy or nitrogen than a different ration. Cows produce a volume of milk, but depending on the components, there's a different amount of energy or content of energy for each of those volumes. And depending on the system, this may have a different economic value as well. Okay? And we feed cows even when they aren't producing milk. In fact, we have to for the first 2 years, right? And then we also have that dry period come along. And so we're feeding cows even when they aren't producing milk. And where do we account for that? Are we going to discount that cow for that period of feed that she's consuming that leads up to subsequent milk production? So given this and the complications of economics that I'm not going to get into, thank you, feed efficiency can actually be quantified in a lot of different ways. We can have fat-corrected or energy-corrected milk per kilo of dry matter intake. We can talk about megacals of energy in milk. We can talk about milk nitrogen, which we're not going to focus on today. And then we can also have some economic indicators like dollars of milk per dollars of feed or feed saved. Okay? So as you can see, we can really get focused in here on how we should in fact quantify it. And as Mike jokingly stated, but it feels like it's the truth in the real life, this is the end, the phenotyping end that those nutritionists Mike showed from each of the universities spend a lot of time thinking about and debating about is how exactly are we going to quantify this to best represent. So first, let's spend a few minutes talking about milk energetics. Not all milk is created energetically equal, right? So I've put together a table here based on how we calculate the megacals in milk, which reflects fat, true protein, and lactose, of course. So we can take then 1 kilo of milk, and depending on if we're thinking about a 4% fat-corrected milk, a 3.5% fat-corrected milk, or an energy-corrected milk, and we can see that each kilo of milk contains a different amount of energy. We can do the reverse if you think in terms of megacals. 1 megacal of milk in each of these 3 different classifications is a different amount of kilos of milk. So how is it that we should compare so that we're comparing truly apples to apples across all of these cows who are producing milk with different components and different composition? And does it even make a difference? So do we spend our times in the weeds here and then it doesn't make a difference? So let's think through just a quick example here, milk per dry matter intake versus fat-corrected milk per dry matter intake. And in our example here, let's have 80 pounds of milk and 50 pounds of dry matter intake consumed. And so this may be if we're thinking on an average cow basis, and we can calculate a feed efficiency out of that. Okay? But what if we then put that in terms of a 3.5% fat-corrected milk per pound of dry matter intake here? And now instead of talking about the average cow making 80 pounds of milk, we have 2 cows. One is making 3.7% fat, and the other is making 3.4% fat, both making 80 pounds of milk a day. And if they're eating the same and we calculate that out, these cows actually represent 2 different feed efficiencies. And so we have to think beyond the average cow We have to account for all of the energy coming out. So in a lot of what Mike set up earlier, we talked about the energy that's in milk or in body mass, and so we have to think about that in terms of composition, not just amount. All right, so how do we measure this? How do we develop the phenotype, and how do we compare then between the cows in terms of feed intake? And I'll show you some of how we're doing that in terms of milk yield and milk composition. And what is the scale that we do this on? Is it by farm? So if we own a farm, we may think about our farm's efficiency on a whole, right? And that's very important as far as farm profitability and farm economics. However, that's not going to help us in genetic selection for more feed-efficient animals. All right, what about by the pen? We often feed pens of cows, right? And there's a lot of value in understanding what a pen of cows can do on average. Okay? A pen of cows may eat a certain amount of feed. But what are we assuming there? We assume that every cow in the pen ate her proportion of that feed, right? And then when we measure milk production, we're taking her individual milk production, and during milk test, we take her individual milk composition. So now we're taking an average pen-based feed intake and an individual cow milk production, and those two don't align. So we have to stay on equal units. We're either pen average base or we're individual cow based. And then milk composition, how frequently we're doing that and how we're working across our DHIs to stay comparable with all of that data. So we can collect a lot of data on a pen level, and in feed efficiency terms, that's fairly easy because you know how much feed you put in front of the pen and you know how much milk that pen of cows made. But again, this doesn't help us select for feed efficiency. And as a nutritionist, what really keeps me excited in this project is it doesn't help me understand the sources of individual animal variance. So what does make one cow more efficient than the other? So on a research side, we're measuring this all in the individual cow basis. So everything's about knowing what that individual cow consumed and what she produced. So a really straightforward way to do that is in tie stalls. These are pictures from Michigan State, and I'll come back and tell you some of the confounders here in a few minutes, but if we have each individual cow in an individual tie stall with her feed in front of her, then we can measure exactly what she ate, and again, I'll come back to that. Another way that we can do this is with electronic feeding gates, okay? Either by using Kaling gates, that's a system we have at Iowa, we have in Florida, and then also for those familiar with the research farm in Marshfield between USDA and UW, we have Kaling gates up there as well. Out at Arlington at our UW research facility, we have Incentec gates, so this is another system of electronic gates. So just to briefly denote the difference here, within a Kaling gate, the cow's in a free stall, but her feeding bunk is much like a tie stall. She has one dedicated place that she can go eat, and it's all by collar. So you can see she has a collar here. She can open this gate, and she is the only cow that gets to eat this feed. Okay? But within the stall, within the pen, it's a free stall setup. So kind of a hybrid between free stall and tie stall there on the feeding aspect. Within the Incentec feeding gates, the difference is that we can set these gates so that every cow can eat from every gate, or only one cow can eat from each, or well, two in our system, but down to 2 cows per gate. So they're in a free stall pen, but then they can also treat the bunk, depending on how we assign gates, like a free stall bunk space. So she can go to whatever bin, again, controlled by an electronic collar, so that's recorded. And we get real-time measurements of feed intake, so we can do things like meal size and meal frequency in this system. So there are some advantages and disadvantages to all of these, which we could certainly discuss further. But if we have one of these tools, then measuring feed intake should be easy enough, right? No, we're still going to overcomplicate this, right? And the truth of the matter is a lot of things can actually go wrong here. There's a lot of things we have to be concerned about or pay attention to. So cows can appear to be very feed efficient if they just become really good at stealing feed from other cows. Because then I didn't eat that donut. Kent ate that donut. I didn't eat it, right? So if you're really good at stealing feed, then either in a tie stall setting where you reach around and eat your neighbor's feed, Or in one of these electronic feeding systems, you shove your head in there and you shove the other cow out of the way. You're eating, but it's not being recorded as your feed intake. So the result, if we didn't control for this, is we could just select for really dominant cows, right? The cows that get in there and steal other cows' feed. The solutions are that we end up having to modify our facilities. So in Mike's tie stall picture here, they have these ingenious little boards, which I actually want to add to the DCC now. If Jessica's in here, I apologize in advance. My wish list is getting longer. And they can actually tilt this bar down and shut the feed off. So when cows leave to go to the parlor and come back, they can't steal other cows' feed. Okay? Within the Incentec feeders, what we've done is we've added additional bars that make it so cows can't reach over and steal, and we've also made the weight to shove down the feeding gate that allows them access much stronger, so it's all hydraulically controlled, and we can make it very difficult for those cows to get in when they shouldn't be. All right, cows can also appear to be very efficient if they mobilize a lot of body stores, and this is one that hits close to home to me because I spend a lot of my effort in the transition period looking at metabolic disorders. So if cows mobilize a lot of body stores, a lot of adipose tissue or protein, then they've got an energy source that we can't account for by quantifying feed intake. And so the result of this could be that we could end up selecting for cows that lose excessive body condition, and that may actually be pretty detrimental, right? So we do a lot of things to control for this. We measure residual feed intake during mid-lactation. We account for body weight change during the period we're measuring it. And here at UW, we've actually been doing a series of studies in the transition period and then following those cows as they go into a feed efficiency study, so determining relationships between that. Another one that could cause a problem in the opposite direction is that cows can actually appear less efficient if they frequently or habitually spill water from their water cup into their feed. And their feed refusals are wetter than what we think they are based on the dry matter of the feed offered. So these are, I comically put here, we could end up selecting for neat cows, cows that don't play in their water or don't fidget. But again, here at Michigan State, there's a bucket outside of the water cup to prevent that. So a lot of things we're thinking about on a day-to-day basis to get as true as a feed intake as we possibly can. All right, so now we have all of this data. What is it that we're going to do with it? And this comes back to the figure that Mike shared earlier, where we have the gross energy of feed and then the energy captured as milk or body tissue. And once we have all of this individual animal data, we can actually calculate both of these. So we can calculate the energy, again, not to ignore, but we could calculate the nitrogen or anything else within the diet. In fact, we do. The gross energy of feed, and we can calculate the energy that she's secreting as milk or a gain or loss of body tissue. And if we look at a figure that's somewhat similar to one that Mike showed you earlier, and we graph all of these animals out in terms of multiple of maintenance here on the horizontal axis, the net energy captured then, or the gross efficiency, okay, is increased as we increase multiple of maintenance, just as Mike walked us through. So as we move to the right of the graph here, we're increasing feed efficiency on the gross energy scale, okay, by increasing multiple of maintenance. But there's a few things here that are really compelling that we can push forward with as we move forward with selection. And that's if we hone in on this cloud here, yes, we increase efficiency as we move to the right, but some of this variance in feed efficiency as we move from these points down in the bottom, looking up towards points that are even above the line here, is not explained by dilution of maintenance. In other words, if we draw a vertical line from top to bottom, there's variance in feed efficiency even at the same multiple of maintenance. Okay? So this up and down variance, if you will, represents a feed efficiency that we can harness independent of multiple of maintenance. Some of this could in fact be measurement noise. Despite our best efforts, there's still noise in real data, right? It's biological data. But some of it is real difference in cow efficiency, and some of this difference is heritable. Okay? So if we can harness this difference, that's what we're referring to as residual feed intake, or RFI. So in a simplistic sense, RFI is the variance that's not explained by dilution of maintenance. It's the difference between what she eats to produce what she's producing and what we think or what we predict she should have eaten to produce that much. And so we can draw that line, that prediction relationship between the milk that she's producing and how much we predict she should have eaten. And cows that are above that line have a positive RFI and are less efficient. And cows that are below that line, these dots here, have negative residual feed intake. They have a negative difference between the line and their actual intake. And those cows are more feed efficient. Okay? So again, I like to show these simple diagrams, but we all know that's not what it looks like. Here's the actual data set. This was as of 13, with primiparous animals in red, multiparous in black. But the line still there is the predicted relationship, okay, between dry matter intake and then the relationship with observed dry matter intake. So dots below the line represent cows that have a negative residual feed intake and are more efficient. So again, we have to account for a lot of things when we're predicting what we think they should have eaten. So note that this predicted dry matter intake is based on parity. And then the factors that represent the energy sinks, all the places that that energy could have gone: metabolic body weight, so the size of the cow, body weight change, if she gained or lost during that period, and then the net energy in milk. Again, on an energetic basis, not just on a kilo of milk. Okay? And then we're accounting for cohort. The reason that it's really important to account for cohort in this is because it then captures differences in the environment between each of these sets of cows we're doing. Was it February in Wisconsin or was it July in Florida when that cow's feed efficiency was measured? Okay? So a negative RFI is what we want, but we also need high production so that we can have productive and profitable animals. So what are the sources of this RFI? How do we capture it and then select for it or feed better to maximize it? This is a pie chart that represents the sources of phenotypic RFI variance. And you'll see diet digestibility here in light blue, metabolism in the dark blue. So this is protein turnover, tissue metabolism, stress. And for those few nutritionists in the room here, we get really excited about these blue wedges of the pie. There's also physical activity, body composition, feeding patterns, and some other variables there. But if we work to understand these and their contribution to RFI, then we stand a better chance in identifying what makes one cow more efficient than another within that same multiple of maintenance. So I'll give just a few examples to try to show our efforts in identifying the categories that can be different by cows and how they could be influenced. So the first one of those examples is on diet digestibility, and this is some work from Mike's lab, so if you have questions, I encourage you to ask him during the panel discussion. I will oversimplify this, which will probably make Mike cringe a little here. But basically, they took a cohort of cows and they fed them two different diets. So they have a corn grain diet or a high starch diet, and then a soy hull diet, so lower starch, more fiber diet. So the corn grain's in red, and it's a pretty flat line, no relationship there, and the soy hull diet is this black line here. Again, we have the residual for RFI and the residual for the dry matter digestibility. So what they were looking for is the relationship to see if the difference in diet digestibility could account for the difference in RFI. Okay? So is it that by feeding a more digestible diet, they were able to improve feed efficiency? And diet digestibility accounted for 10 to 30% of RFI variance when cows were fed the low starch diet, but not when they were fed the high starch diet. Okay, so there's some truth in this, but it's dependent on the diet. Okay, so there may be room to maximize feed efficiency, but again, we're going to have to be very aware of what the diet composition is that we're feeding. Another area that digestibility could be playing a role in RFI is as we think about the microbial population within the rumen. So I've had the great fortune to be on a committee in microbiology, Madison Cox, who's here today following up with Garrett Suen and Paul Weimer's work, with the microbial population within the rumen. And this was an area that's a little bit out of my wheelhouse, so it's been a lot of fun to get involved in. But basically, they paired up, for those who aren't familiar, the first paper was in 2010, so many of you may already be aware, but they paired up high and low feed efficient cows And they characterized the microbial population within the rumen. And they found that there were distinctively different populations between the high and the low efficient animals. And so in a study, they emptied out the rumens. So here on the right, this is low efficiency, pre-swap is the green, and high efficiency, pre-swap is the red. And so those populations are distinctive. And what was really unique is they emptied the rumens, and these are really fun experiments. They washed and swapped contents. And what's really cool is the high efficiency, when they put the rumen contents into a low efficient animal, they actually caused a shift, this orange circle, where the low efficient cow's rumen contents started to look like the high efficient. Okay? And her characterizations were a little more similar to the high efficient animals. But within a week, she was back to her old one. She was back to her old population. And the same thing happened when they took the low efficient animal and they swapped rumen contents with high efficient. This blue circle here represents she became more like the high efficient microbial population. But then again, within a week, she's back much closer here to the green ellipse. And so there's a lot of really interesting implications from this in that there may be a host and microbial population interaction here. But certainly some unique aspects of low and high efficient animals. But the fact they return 1 week post-transfer really suggests there's a role of the host in this as well. So one last thing to highlight here that we're starting to work on within my lab is that once we have a diet that's completely digested or as digested as it will be, and those nutrients are absorbed, there's a lot of things that happen post-absorptive. Okay? So one of those other wedges with metabolism, that was a pretty big piece of that pie, one component of the mini within that is how those nutrients are used after absorption. So how they're used by the liver to make glucose or to make fatty acids used by the mammary gland, how that is intersecting with fatty acid mobilization from adipose tissue, and then how the mammary gland uses that to convert it into the milk and the milk components that are actually obtaining profit. So post-absorptive tissue use may vary in efficient versus low efficient cows. And we've been looking at both the liver utilization of these nutrients, but also in the mammary gland uptake and conversion of the nutrients into milk. So our preliminary work really points to the fact that this may explain some variance both between high and low efficient animals, but may also explain some variance between primiparous and multiparous animals, especially as we look at those RFI graphs where the primiparous and the multiparous are clustering differently. Okay. So I'll wrap up here with a few take-home points. Precision is certainly key in measurement of anything related to feed intake and feed efficiency. We can very quickly misclassify a high or low efficient animal as the opposite if we're not ensuring that we're controlling the feed intake quantification and also on the energy output side. Residual feed intake represents the difference in feed efficiency not explained by dilution of maintenance. And this is the difference between what the cow ate versus what we predict she should have eaten or could have eaten. And this is really, as Mike set up earlier, this is really a window where we could have a lot of opportunity as we move forward selection for feed efficiency. There are many biological sources of the variance in RFI between individual animals. Understanding the contribution of each of those, or at least some of those key ones, will likely help further clarify animal-to-animal differences and help us in selecting for more feed-efficient animals. Some of these digestibility and rumen fermentation are being worked on across several of the universities in this project. Post-absorptive nutrient utilization, something that we're working on in our lab, and a new aspect of feeding behavior and competition at the feed bunk, which we can mimic within the Incentech feeder, may allow us to look at that component of social interaction as well. All right, so acknowledgements, Mike showed the whole team, but at UW, Kent Weigel, myself, previously Lou Armentano on the project when it was the USDA project, and a whole team of individuals that it takes to get this done. All of those meticulous feed intakes and dry matters don't get done themselves, and then certainly acknowledge the funding sources and CDCB for the collaborative efforts. So with that, I think I've caught us up for milk break, or pretty close to it. I'd be happy to take a question if there's time for one. Thank you.